Alright, so we're going to be looking at functions and parent functions. And what I want you to get out of this, guys, is that if you learn your parent functions, really the rest of what we do is easy. Okay? If you know the parent functions well, you can learn the basic transformations, and the rest of it is pretty easy. Okay? Alright, so let's just real quickly review here. When we're talking about functions, alright, we're dealing with domain and range. Okay? Domain and range are two terms you ought to be familiar with. When you hear domain, you probably think X. When you hear range, you probably think Y, because those are sets of numbers. The domain is the set of all numbers that X can be. The range is the set of all the numbers that Y can be. What you may not remember necessarily are these terms here. The domain, or the X, is our independent variable. Okay? It's our independent variable. The Y is like the result. It's the outcome. After we plug in an X, it's the outcome. So we say it's dependent on the value of X. Alright? So we call it the dependent variable. Alright? So I want to look here at a couple of these. I want to look at inequality and also interval notation. But actually start with one that doesn't really have either of these, because this is not continuous, it's discrete. In other words, that we're just dealing with individual points, individual values here. Okay? So for our domain, we could say here, you know, what does X equal in this case?
5, 1, 3, 30.
What does X equal?
It 1, 2, 3, 4, 5.
Yeah, 1, 2, 3, 4, and 5. It doesn't equal 1.5 or anything between. So here what we could say is X is an element of, that's what this little E looking thing is, and then we can make a set. This looks just like the lists that you put on your calculator. Okay, that's set notation. The set 1, 2, 3, 4, 5. Okay? So X is an element of that set. And then for the range, okay, we would say Y is an element of what set? What's in our range here? 1, 3, and 5. Okay? 1, 3, and 5. Alright, so that's pretty easy. Those are just points. Okay? So we're just listing the points, the values in a set. Okay? Now, let's get to ones that are a little bit more like what we will probably be dealing with. Okay? And also look at both inequality and interval notation. Okay? So, how would you describe the domain here? What can X be in this example right here?
1 through 5, anything?
Yeah, anything from 1 to 5. So as an inequality, we would simply say X is greater than or equal to 1, but less than or equal to 5. Okay? Now, does anyone remember how you could write an interval, or what that notation would look like?
Yeah, wait, interval. Isn't it like
parentheses, number, comma, number, and parentheses?
Okay, parentheses or...
If it's less than or equal to, it's parentheses, but if it's not, it's just less than, and then it's kind of more square in the bracket.
Okay, actually...
It's the other way around.
The other way around, okay? But yeah, you guys are remembering well. All right, since it can equal 1, we use a square bracket here, and it goes from 1 to 5. And we put a square bracket there because it's allowed to equal 5 as well. Okay? Now, what about our range? Yeah, it's going to look basically the same, except in this case, it's y is between 1 and 5 inclusive, but the interval actually does look identical. Okay? Because y is also going from 1 to 5. Okay? So this notation, this interval notation, is something that I want you to be able to use. Yes, Susie? Oh. What? Okay? All right, so finally we have this one. Now it's not just line segments, and it doesn't stop when it hits 5. Okay? So what would we actually say about x in this case? What can x equal?
All real numbers.
Yeah, all real numbers. It's going to go to infinity and negative infinity. Okay? So if we're looking for inequalities, okay, we could say, we could actually use some of the set notation a little bit. X is an element of the real numbers. X is any real number. That's what that says. Okay? For an interval, though, notice now I'm using parentheses, and we would say negative infinity to positive infinity. Okay? And notice here I use parentheses because infinity isn't a value. You can't equal infinity. All right? You just keep going and going, so you're approaching infinite. Okay? Now, what about the range? How would we, what is the range of this function?
Y is greater than or equal to 1.
Very good. Y is greater than or equal to 1. And as an interval, someone tell me how I could write that as an interval. Ryan?
Close bracket 1, infinity, positive infinity, open bracket, open parentheses.
Okay, good. So that's how we would write that. A bracket with a 1, comma, infinity, and then the parenthesis. Okay?
Shouldn't it be positive and negative?
If you don't have to put the positive, if you want to, you can. If we don't see it, we assume it's positive. Now, by the way, this, just a little bit about interval notation. When you have brackets on both sides, we call this a closed interval. Okay? Because there are definite endpoints there. When you have parentheses on both sides, like this one here, we call that an open interval. That means the ends are not part of the answer, so we're just getting closer and closer and closer to the ends. When you have one like this, what do you think we call that? When one side is closed and one side is open.
Indefinite.
Closed open.
Mixed.
See if anyone comes up with it. We actually just call it a half-open interval, okay? Half-open interval, okay? You don't have to know those terms necessarily, but especially if you go on to calculus, a lot of the theorems, they'll talk about a closed interval or an open interval, so those are useful to know, okay?
Why not half closed?
I don't know. I guess it's, is the cup half full or half empty, So, I guess half open seems more freeing or something. All right, so let's take a look at a few examples here. Here's a function, Okay, do you know what this blue function is called? Well, it has those. It has asymptotes. But do you know what this shape is called? It was one of your conics.
Yeah. I know.
Yeah.
Okay, no.
A hyperbola, okay? This is a hyperbola. And you're right, these are asymptotes, these dotted lines here, okay? So I wanted to look at this one because you have a couple of options about how you're going to express your domain and range in this case, okay? What would you say about x for our domain? What is x allowed to be?
Whatever it wants to be.
Greater than 2 and less than 2.
Okay, it has to be greater than 2 or it has to be less than 2, right? It could be greater than 2 or less than 2. It's not allowed to
Be 2.
equal to, yeah. So you have two, here's where the options come in. You can write it like this: x is less than 2 or x is greater than 2. Or an alternative is just to say x does not equal 2. When you say that, we automatically assume that since you pointed out it's not allowed to be 2, that it is allowed to be any other real number. Okay? So that's just one of the things we automatically will imply or infer from that, is that if you say it's x does not equal 2, we automatically assume that it can be any other real number. Okay? Now, the interval for this, there's not a really slick way of doing it like there is with the inequality. So all you've got to do here is actually, you have to do the two different intervals. Infinity up, negative infinity up to 2, or from 2 up to positive infinity. And notice both of those are open intervals. Neither of them allow it to equal 2. Okay. So then what would I do with the range?
Y is greater than 2 or it's less than, 0.
Okay. Y is greater than 0, or y is less than 0, or what could you also say?
Y does not equal 0.
Good. Y does not equal 0. And then, of course, again, your interval is negative infinity up to 0, or 0 up to positive infinity. Okay? All right, let's try one more. Okay? Let's try one more. This is a little different kind of a function. All right? This is all one function. Does anyone remember the name of this type of a function?
Step.
I think we're learning this in physics, right? It's a vector.
Oh, piecewise.
Well, these look like if you were drawing vectors.
Piecewise.
These are piecewise functions, yeah. It's where we have different functions that we're going to follow depending on what value of x we're dealing with. Okay? So for example, when x is less than or equal to negative 2, we're going to be on this line here. However, it's not even defined between negative 2 all the way up to negative 1. But then once we get past negative 1, we jump over here to this line. Okay? So, for our domain in the inequality, we could say that x is less than or equal to a negative 2, or x is greater than 1. Okay? And again, the interval, it would be negative infinity up to negative 2, or I'm sorry, what do I need here? Yeah, I need to half close this interval with the bracket there. Alright. And then from -1 with the parenthesis up to positive infinity. Okay? What would the range for this one be, though?
1 greater than or equal to.
Okay? What do you guys think about this? Y is greater than or equal to -3.
No, it's like if you for when x is -2. Is there gonna be 2 of them?
What do you think?
Would it be between both of them? No.
Well, what is a range? A range is...
The least, the greatest distance, kind of.
I don't know, a range in our functions, not range statistically, but a range in functions.
Yeah, where it starts and where it ends.
Okay, where y starts and where it ends, right? So y, the lowest y ever gets is -3, right?
Mm-hmm.
And does it ever end?
No.
No. Even here at 1, notice there's an open point here at 1, but it does equal 1 on this part of the piecewise function, so that's okay. So it does include everything greater than or equal to -3.
That should be a negative.
Okay. Oh, yeah, thanks. Okay? Now, these piecewise functions can look a lot of different ways, okay? Here we have one that looks like this, and you can actually see the parts of the functions that we're not using. Think about it this way. This is like following directions on Google Maps or something. Okay? The whole road exists here, right? This whole road exists, and this whole road exists. However, according to this piecewise function, we're going to follow the line for all the values of x less than or equal to 2. So here's, or -2. So here's where x is -2, and we're going to be on this part of the function, we're going to be on this line forever to the left. Okay? However, what this second part says is it says once we get past -2, so I'm going to put an open point here, we're going to follow this road. Okay, it's like we turned onto a separate road. So now we're on this parabola, and we're going to follow it for the rest of the time. Okay? So that's what a piecewise function is. It's just telling you follow this function for this range of x's, follow this function for this range of x's. Okay? Here's another one. We're following x squared when x is less than 0, so all the way up approaching 0 here. But then we're going to jump over to the square root of x once we hit 0. Well, that just happens to be right on that same point, and you go like this. Okay? Now, both of these first two examples, the two pieces ended up meeting at a point. That doesn't have to be the case. Like in the first example I gave you, okay, how would we define this function? Well, if this is function f of x, okay, we're going to have one function, one line that we're following when x is less than or equal to -2, but then we're going to follow a different line once x gets past -1. Alright, so you'll notice here, it's kind of like I have two little domains. Alright? And I put those with a comma. Now, you guys know how to find the equation of a line, so we'll kind of go through this quickly. This one hits at 2, and it has a slope of 1, so this is just x plus 2. This other one has a slope of -2, and if we keep going, we're going to hit the y-axis at -7. So -7, that's a -2x minus 7. So that would be the definition of that piecewise function. Okay? All right. Have a great day, guys.